Voyager's terrifying new discovery shocks the entire space industry. Outer space is a mysterious region that humans have been trying to explore for years. From the making of the first telescope to the latest James Webb Telescope launch, the discoveries made were fascinating and horrifying at the same time. Almost 13 types of spacecrafts have made their journey in space, and one is Voyagers 1 and 2. Both have provided essential information about space. But what is the recent discovery that has terrified the scientists? And how does the discovery affect humans on Earth? Stay with us so you can know. Greetings. In this video, we are going to know about spacecraft Voyager 1 and 2, what discoveries they have made, and the recent data that has disturbed the whole space community. Watch the video and give it a like and share. Without any delay, let's start. Both Voyager 1 and 2 were launched into space in 1977. The initial mission of both crafts was to find out more about the planets and their satellites. Years after their launch, both spacecrafts are still providing vital information and pictures despite being in deep space. Initially, Voyager 2 was destined to study Jupiter and Saturn only. But after its success, the scientists extended its mission and it was sent to study Uranus and Neptune as well. So what makes the Voyager work in the first place? The Voyager 1 is not solar operated, as they would have stopped without the sunlight. The twins work by generators, or RTG, that use a radioactive isotope, plutonium-238. As a radioactive isotope decays, it produces heat, which is converted to electrical energy. The half-life of plutonium-238 is 87.7 years, so the Voyagers can last for many years in space. The mechanism of sending signals to Earth is a little different. The twins have small thrusters that work on hydrazine fuel. This allows communication between Earth and the twins. An interesting fact about Voyager 2 is that after 37 years, the thrusters ran without fuel, and scientists turned on the backup thrusters that were off for 40 years. These thrusters worked perfectly fine even in the deep space with no light. Voyager 2 has made a massive discovery, as it has become the second spacecraft to enter interstellar space in 2018. Interstellar space is the region between the stars and the closest thing to a vacuum and space where the sun effects end. Voyager is currently 119 astronomical units away from Earth. The average distance between Earth and Sun is 1 AU, which is equal to 93 million miles. Voyager 1 is currently at 159 astronomical units away as it entered interstellar space earlier than Voyager 2. But the Voyager 2 was the first spacecraft to study the outflow of charged particles, low-energy ions, and electrons. Keep in mind when Voyager 1 crossed the helipause boundary, all its instruments were damaged, so it was not able to detect changes in plasma and magnetic field when it entered interstellar space. On the other hand, all the instruments on Voyager 2 were in perfectly fine condition. The instrument on Voyager 2 was able to calculate the jump in electrons, protons, and particle density as they struck the spacecraft in high motion. The Voyager 2 plasma science experiment helped determining the flow of speed and direction, density, and temperature of the plasma. The current mission of Voyager 2 is to give the idea of the direction of solar winds, its interaction with planets like Jupiter, Neptune, Uranus, and Saturn, nature of ions in interstellar space to detect the natural boundary between heliopause boundary and interstellar space, the interaction of solar winds with heliopause and the direction, interaction, and nature of magnetospheric plasma with planetary system and their satellites. By far, the Voyager can get information on all these points. To understand the discovery, let's take a look at the structure of the solar system and interstellar space. Our solar system is the space that is created by the magnetic field of the sun, known as the heliosphere. This region is created from the constant flow of particles and a magnetic field from the sun into space over 670,000 miles per hour. This stream of particles is called the solar wind, and it affects all the planetary systems in our solar system. The place where this stream ends and creates a magnetized bubble of plasma is called the heliopause, and beyond that, a new region starts where there is no effect of the sun's magnetic field. This region is called interstellar space. So how did scientists know we have entered interstellar space and crossed a heliopause? Since 1992, antennas on spacecraft were detecting low-frequency radio waves. These waves remained a mystery for scientists for many years until Voyager 2 entered the heliopause. However, it was estimated that these radio emissions were the most powerful radio source in the solar system. The total power emitted by signals was more than 10 trillion parts, but with a low frequency of 2 to 3 kilohertz. They are not detected from Earth. The mystery was solved when Voyager 2 entered the heliopause and collected the data. What did the data reveal? At the distance of more than 11 billion miles from the Sun, its magnetic field thins out and is opposed by a much stronger magnetic field created by the destruction of stars a long time ago. The region between these two fields is the heliopause, a form of a bubble that protects all of our solar systems. When Voyager 2 got close to the heliopause, the speed of solar wind dropped to zero, fluctuated, and then rose again as compared to Voyager's 1 data, where the speed of solar wind dropped to zero and rose after a long duration. The plasma surrounding the heliopause, which is close to interstellar space, slows, heats up, and gets denser. Voyager 2 estimated the temperature of the heliopause to be 89,000 degrees Fahrenheit, but inside interstellar space, the plasma is too thin and the temperature drops to negative 454 degrees Fahrenheit or 3 kelvins. Voyager 2 also disclosed that the heliosphere is a leaky boundary where magnetic field takes from both sides. As Voyager 2 observed, a thin trail of solar magnetic field extended some 100 million miles inside interstellar space. The data collected by the two Voyagers differ to some extent. The reason is due to the time they have entered interstellar space and their trajectory. Voyager 1 entered interstellar space in 2012 and Voyager in 2018, when we were in a period of a solar minimum. Also, when Voyager 1 exited the heliopause from the leading edge, where it collided with the interstellar medium. On the other hand, the Voyager exited the heliopause from the left flank. But most of the data provided by Voyager 2 backs up the facts provided by Voyager 1. The surprising thing, when both Voyagers entered the heliopause and then interstellar space, the direction of the magnetic field remained the same, even though there was a clear difference in the strength of magnetic fields. The reason for this is yet to be found. The shape of the heliopause also remains a mystery for scientists, as there is no evidence to support it of its round, elliptical, or a sphere. The scientists are hopeful to collect more data from the twins in 2025, as the Sun activity will be at its peak again. Nonetheless, the role of the Voyager in the discovery of our solar system cannot be neglected. While passing through 4 planetary systems, Voyager 2 revealed many important facts. The Voyager was able to discover the first moon of Jupiter, taking 33,000 pictures of the planet. Uranus Voyager discovered 10 new moons and 2 rings, and in Neptune, Voyager 2 discovered 5 moons, 4 rings, and a great dark spot. All these discoveries and data changed our perspective on these planets. Future of Voyager 2. With the mission of never coming back to Earth, the Voyager 2 has enough electrical fuel to last in space for many years. In the year 2025, Voyager 2 will be 11.4 billion miles or 18.4 billion kilometers away from the Earth. With time, Voyager 2 is losing its instruments one by one. As of 2022, 5 instruments are sending us data that reaches us in 19 hours. According to the scientists at NASA, both golden records are highly likely to survive at least partially intact for a span of over 5 billion years. And in this span, the Voyager 2 is likely to cross our Milky Way and enter into an entirely unknown region. Who knows what will happen to Earth in these 5 billion years? This ends our video for today. Tell us, how did you like the discovery? Subscribe and like our channel to see more discoveries like this. Give us suggestions on what you want to know. See you in the next video.